Good morning, all. So now we are starting our discussion, and I think all of you will agree with me. This statistics has a lot of importance, or you can say, measurements. They have a lot of importance in our life. In the beginning of the civilization, we were little confused. Why? What is longer? What is shorter? What is heavier? What is lighter? There was lot of subjectivity. There were no definite means of comparison. Then we learned art of this measuring, numbering, and weighing. This came as rescue to our understanding related to many things. Now these things are no longer mystery over us. You can say measurement is a kind of language. When we are measuring something, good measurement is very important. And how we define good measurement? By their accuracy, these are close to true value. By their precision, if we are measuring number of times, we are getting the same measurement, and it should be as per our requirement. As per requirement means, if suppose you are defining something, suppose you are defining glucose level, you are saying glucose level is 140, it is okay, or 140.2, even then it is okay. But if you are saying glucose level is 114.2346, then that much correctness up to that much significant numbers, it is not required. Or if you are saying glucose level is 140 milligram per dl, it is okay. But if you are saying it is 1400 milligram per liter, although your measurement is correct and it is the same thing, but then it will not be considered as meaningful because we are not expressing it that way. But, or if you are saying this much kilogram or this much microgram, we are not expressing in that way. So we have to see our measurement should be correct and should be communicated appropriately. So now, how we will be using these measurements in our laboratory, that we will see. In our laboratory, what is required? Everybody expect a quality control system. What is this? This is something how we are working in our laboratory. Whatever quality control system we are developing, and it is not including only examination part, it is including pre-examination as well as post-examination. It should be well documented, understood by the people working in the laboratory, and it should serve some purpose. It is supporting continuous quality improvement. You are able to improve the quality of our laboratory, and laboratory is able to demonstrate through its various activities. There is a system in place. These are not just series of uncoordinated activities. People, they are collecting sample properly, but samples are lying there. They are transported very late. And you may be wondering, instead of mathematics, why I am talking all these things. We will come to that, but before we have that, we have to realize why all these things are important in our laboratory. And whatever we are doing in our laboratory, time to time, we shall conduct audit. That means we shall examine our activities based on some criteria. If we are examining these activity ourselves in our laboratory, this is called internal audit. And if we are going for accreditation or some regulatory body or accreditation body, they are sending their people to examine our activities, and their assessors, they are submitting their report to them, and they are issuing us some endorsement. This is external audit because they are not in our control. When we are examining our activities, this is called internal audit. We may examine ourselves or we may call somebody from outside. But in both cases, we are deciding about the audit. The both are considered as internal audit. Because when we have this quality control system in place, only then we can assure somebody else. First, we have to ensure ourselves. Then we can assure clinician, we can assure patient. Quality management system is in place and we are following that. So for that, what is required? We require a quality system, quality management system, which is well documented, well understood, and well implemented in the laboratory. Which is well documented and well implemented in the laboratory. What is the advantage of this? We are able to detect a significant error before it is detected in the patient result. And we are able to release result in a timely manner. We are following our turnaround time, and we are able to run our lab in a cost-effective manner. And if there is any error, first we are identifying that, then we are doing root cause analysis, why this thing is happening. And we are following latest trends in our laboratory, how we can detect error at the earliest stage. So that is why we are learning this Six Sigma also, because this Six Sigma is being used, and we will also discuss lean concept, because these things are used in the laboratory for maintaining quality and for removing wasteful expenditure. Most of the time what happens, people are a little confused. In the morning, this control is out of limit, not within the accepted range. Now, what is required? Sometimes people say, forget about it. You start running patient sample, or you keep on running control till you get the correct result. That is not the correct approach. Identify there is a problem, root cause. When you will start working on it, then you will develop better understanding, because there is not a single book which can give you proper knowledge about how to decide about the controls and how to do the root cause analysis in case of any outlier, and what is the best corrective action in a particular situation. These things we learn with our discussion, and when we start following these quality requirements. So this is what I said. If you are ignoring, that is not the solution. If you are repeating control till you get the correct result, that is also not the solution. Best approach is find out what is the reason and fix that. Because whatever is happening to a control sample, same thing can happen to your patient sample also. A good habit is identify the problem, root cause analysis, document it, take appropriate action, then again document it, monitor your corrective action for its effectiveness, and see it is not occurring again. Important thing is, whatever you are doing, document. Because with this documentation, if suppose you are reviewing after 5 months or 6 months, then you will come to know what all you have observed in the last 6 months. Because problems happening in a particular laboratory, those problems are generally unique to that laboratory. Different laboratories, they have different type of problems. Then you will be able to understand your laboratory in a better way. Important thing is, whenever there is anything which is not happening as per the system, you have to see, is the error clinically significant? And if it is significant, how many results I have released after the last successful QC? Sometimes, based on your standard deviation, we will discuss all these things, based on your standard deviation related to that parameter, something is showing statistical error. In terms of statistics, error means variation, but it may not be clinically significant. You have to understand, you have to document. Do the test need to be repeated? If the test need to be repeated, so then you have to recall all the results which you have released after the last successful QC. But important thing is, do not release any result which you have not released yet till you are rectifying the problem. And whenever you find any pre-examination deficiency, communicate to clinician. What may be pre-examination deficiency? In your hematology, suppose in 2 ml EDTA tube, somebody has collected 1 ml EDTA, 1 ml blood. Then excess EDTA may cause shrinkage of red cells. It will reduce your MCV. Now, if suppose some clinician is examining normal hemoglobin, normal RDW, low MCV, what will come to his or her mind? Am I dealing with some hemoglobinopathy trait? Now the person is asking for HPLC for hemoglobinopathy. If that is coming normal, then they are asking for CBC again, and that is coming normal. What is the reason? That pre-examination deficiency. We have to evaluate our reports very carefully, and there is any such situation, so that shall be informed to clinician. This is the reason you are getting this variation. If you want, you send sample again, so we will repeat. Because sometimes they are interested only in TLC, or they are interested only in hemoglobin. They can take appropriate action on that. So now we will start our discussion related to these statistical terms. In this we will discuss mean, we will discuss standard deviation, we will discuss coefficient of variation. So we are discussing statistical calculations which are useful in our day-to-day laboratory practice. We are not discussing here anything related to our research work, student t-test, chi-square test, or significant p-value. What is mean? Sum of all data points divided by total number of data points. Now, what is the significance of mean? And all these things we are calculating on our IQC data. Because for any of these calculations, we require multiple data points, and we are generating multiple data points in our IQC. Equus sample, we are running only once. So we cannot calculate any mean, any SD, or any CV. Equus provider, they can calculate because they are getting results from so many laboratories. They have different values, different results on the same sample. They can calculate, but we cannot calculate. So we are calculating on our IQC data that we are running on a daily basis. What is the importance of mean for us? Mean tells us about accuracy. What is accuracy? How close our result is to true value. How mean is telling us? If suppose manufacturer mean is 100 for glucose and your monthly mean is 90 or 110, it is significantly away from the manufacturer mean. That means number of values, they are away from the target value. And when these values are away from the target value, this is considered as inaccuracy. So mean tells us about inaccuracy or problem in accuracy. Now when we are discussing mean, you may ask which mean is better, manufacturer mean or calculated lab mean. Yes, Dr. Vijayshri, please unmute yourself.
Sir?
Yes, Dr. Vijayshri, where are you from?
Coimbatore, sir. Yes, sir.
Okay, and what is your specialty? Pathology, microbiology, or biochemistry?
Microbiology, sir.
So,
Yes, sir.
you may not be used to all these things, mean, ST, CV, etc., because application in your microbiology is limited. But
Yes,
these days, we are losing these boundaries of differentiating our laboratory medicine into pathology, microbiology, and biochemistry, because when somebody is lab director, that person may be pathologist, microbiologist, or biochemist,
yes,
right?
sir. Yes,
So
sir.
everybody has to develop understanding related to different activities of laboratory. So that is why, with that intention, I think you are attending this program. I also
Yes,
should have
yes, sir.
understanding of all these things. So now, what is your opinion? Which mean is better? Manufacturer mean or mean which laboratory is calculating in the laboratory?
I think laboratories calculating mean may be more important.
Can you think about it? Why calculated lab mean is better?
It will be according to our sample.
Yes, excellent. See, this you are defining in your lab, your laboratory conditions are different. Your environmental condition of the lab is different. Your wear and tear of the machine is different. Your reagent storage is different. Quality of your reagent is different. Your calibrator storage, control storage, water quality,
Yes,
wear and tear of the machine, competence of the observer. There's so many variables which can affect a result, right?
yes, yes, sir. Yes.
This you have to calculate mean in your laboratory. Now the concern is, okay, thank you, Dr. Vijayshri. Very good.
Okay.
Yes, Dr. Kavita, please unmute yourself. Kavita, one thing is clear. Kavita, please unmute yourself. After.
Hello, sir.
Yes. So whenever I ask you to unmute, it is for all of you.
Okay, sir.
Remove the cursor from that button, because if that cursor is on that mute button, if this gets pressed, so again you will be muted.
Okay. Sure, sir. Sure, sir.
And Kavita,
Sir,
where are you from?
Sir, I am right now in Madhya Pradesh, Indore, and I'm a biochemist.
Okay, very good. Now, we are one thing is clear: calculated lab mean is better.
Yes, sir.
But we also have to understand whatever mean we are calculating, it is not significantly away from the target value.
Yes, sir.
Otherwise, there will be a lot of inaccuracy. As we discussed, lab mean is 100, but 90 is not acceptable.
Correct.
It is not acceptable.
Correct.
But we have to understand whether this 95 is acceptable or 96 is acceptable or 98 is acceptable. How we are defining this acceptability criteria? What is acceptable and what is not acceptable? Or how much variation is acceptable? So what we can do for our laboratory, we can say, whatever mean manufacturer is offering to us, whatever standard deviation manufacturer is offering to us, our mean should not be more than one standard deviation away from the manufacturer mean.
Correct.
And our standard deviation shall not be wider than the manufacturer standard deviation.
Yes.
Suppose manufacturer mean is 100, standard deviation is 2, our mean should be between 98 to 102, right? And our standard deviation shall not be wider than this manufacturer standard deviation, that is 2. So that way we develop objectivity in our system. Okay, this is what we are accepting. So now the thing is, where are you, Kavita? Please keep yourself unmuted because I have not asked you a single question. I want to.
Okay, sure, sir. Sure, sir. Yes, sir.
Now, Kavita, situation is, we are saying one standard deviation is acceptable to us, right?
Yes, sir. Yes, sir.
And suppose first month your mean is 99.7.
Correct.
Second month your mean is 99.4. Third month your mean is 99.2. Fourth month your mean is 99.0.
Okay.
Both are within one standard deviation.
But they is showing trend.
Is this situation acceptable to you?
No, sir. It is showing trend. So there is some systematic error which is going on.
Moving in one direction.
Yes, sir.
It is moving in one direction. This is called trend.
Yes, sir.
All four values independently, these are acceptable.
Correct.
This pattern of result is not acceptable.
Correct.
It is
Yes, sir.
moving in one direction, as you rightly said. To show some systematic error. What are random errors? What are systematic errors? That we will learn.
Okay.
But one thing is clear: this is not acceptable because this, at a stage, this may cross one standard deviation and will become unacceptable.
Correct, sir.
So we have to understand this.
Yes, sir.
And mean is used in the calculation of standard deviation also. Mean is used in the calculation of coefficient of variation also. Mean is also used in plotting Levy-Jennings charts that we will see.
Okay.
These are the various concepts related to statistics.
Okay.
So, yes, Kavita. Now the question for you is,
Sir.
tell me one thing.
Hmm.
You are calculating your own lab mean and you are saying lab mean is better, right?
Okay, sir. Yes, sir.
When you are getting a new batch of control,
Yes, sir.
what you will do in the first month?
Sir, a new batch of control, we do lot to lot variation before using the new control. And then previous CV, sometimes we used to set our new standard deviations, sir.
You will use previous SD to standard deviation,
CV,
right?
CV, sir. CV, sir. Yes, sir. Coefficient of variation.
We will discuss SD and CV both, then you will realize, because if you want to settle down standard deviation, so you have to use standard deviation.
Sir.
Settle standard deviation with the CV.
It's a CV. Yes, sir.
My question is, if
sir.
you are getting a new lot of control, because you are plotting Levy-Jennings chart,
yes,
for
sir.
that you need mean and SD. How you will decide mean for the first month? What will the mean?
So if the new lot has come QC lot, so ideally they say there are two ways. Either you follow the manufacturer mean for 20 data points and set your lab mean and standard deviation. But what we are doing in practice is the CV, which is acceptable CV, we are taking and we are calculating the standard deviation for the new lot. And we are following it for another 20 data points and then reassessing our lab mean. Am I right, sir?
Kavita, just a minute.
Haan, sir.
You will use
Haan.
the previous standard deviation.
Haan, sir. So, CV based on the CV, calculate the standard deviation for the present one. Acceptable CV. If it is 4%, then based on that, calculate the standard deviation.
You have some confusion in your mind. Suppose the previous CV is 2.
Sir.
So how you will use that? How you will calculate standard deviation from this 2?
So using the formula, the mean. Okay, I got your point now. Okay, how you will set the lab mean, because now for that you require a mean also. Okay.
So in the first month, which mean will be used by you? This is what I'm asking.
The manufacturer's mean for 20 data points?
Based on 20 data points, you will recalculate. But on day 1, which mean will be used by you? After 20 days, you have 20 data points. What are the first?
Manufacturer mean?
Okay. So now one school of thought is you use manufacturer mean, manufacturer standard deviation. That you use for 20 days. And after 20 days, you will have 20 data points. And then you will start using your calculated mean and standard deviation, right?
Correct. Yes, sir.
What you are saying.
Yes, sir.
Now, yes, okay, thank you. Yes, Bhashwati, please unmute yourself.
Yes, sir. So we are doing a different thing in our lab. It's like...
Just a minute. What is your specialty?
Yeah, I'm a pathologist from Ranchi.
From Ranchi?
Yes, sir.
Okay. Now...
So, sir, what we are doing is slightly different. It's like when the older lot of control is being run and the new lot arrives and we know that, it's going to be over in a month. So we run the new control simultaneously with the old control. And then we get our 20 data points. So when the new control is starting, we are moving on to the new control mean. It's already, the data is already there with us.
So right. So now one approach is, as Kavita said, we will use manufacturer mean and SD for 20 days. You are saying we will run new lot in parallel, and that mean and SD we will start using when you will use this new batch of control for deciding whether this particular, on a particular day, patient, this variation is acceptable or not. Right, Bhashwati?
Yes, sir. Yes, sir.
So both are okay, both are acceptable. Only thing is, whatever you are planning to implement in your laboratory, document your IQC in that way so that it is clear to people working in the laboratory how they have to proceed. And it should not vary from month to month. In the same laboratory, this month, Dr. Kavita is reporting for 6 months and they got new lot of control and they are following manufacturer mean and SD. After 6 months, Dr. Bhashwati is reporting. So now they are following this calculated lab mean and SD. So this should not happen. Whatever system you want to develop, you develop and implement in that way. This is what I want to say. Right, Dr. Bhashwati?
Yes, sir. Yes, sir.
Now the question for you, Dr. Bhashwati. Suppose there is a situation. You have to implement new batch of control from say 6th of September and you are receiving new lot today. What is that? 30th of August.
Yes, sir.
Now what will be your approach? For some reason you are receiving today. So now you have only 6, 7, 8 days. Can you do something? Follow manufacturer mean and SD.
We will follow the manufacturer mean and SD. Or like if I have, like we are running the control at least twice daily. So we will anyway get our data within 3-4 days. So I am a bit confused about what to do.
So now what you can do in this situation, this is mentioned in CLSI document A104 A104, Quality Management System in Medical Laboratory. They say what you can do if you have less than 20 days, you can run these controls 4 times in a day in different batches for 5 consecutive days. If suppose you have 10 days, then you can run these control twice in different batches for 10 days. You will generate 20 data points. If you have only 5-6 days, so you can run in 4 different batches on the same day and follow this activity for 5 consecutive days. So you will be able to generate 20 data points based on your analysis, and you can calculate mean and ST. So this is mentioned in CLSI document A104. If you have less days, so you can follow this practice also. So whatever you are doing, but again, it is the documentation which is very important.
Yes, sir. Thank you, sir.
Right?
Yes, sir.
Yes, Kavita, please unmute yourself.
Sir, I have one small query. If we do it for smaller days by increasing the number of quality control, will not our range become very narrow?
Yes. What is the statistical formula used to decide about this range?
Mean plus or minus standard deviation. I'm talking about standard deviation, sir.
Yes.
Wouldn't that become very narrow if we are choosing?
Just a minute, Kavita, I'm coming to that.
Okay,
Mean
sir.
is a fixed value. What
Acha, sir.
you're getting, it is not narrowing your range, right?
Okay. Okay.
Now, this standard deviation will narrow your range. If suppose standard deviation is very less,
Uh-huh.
whatever you are using, you are saying
Sir.
is between 2 standard deviation is acceptable to us.
Correct, sir.
Plus 2. If this standard deviation is very small, so you will have a narrow range, right?
Yes, sir. Yes, sir.
So now, what is varying from lot to lot, meaning standard deviation is based on your different aspects related to measurement. Your water quality, your observer, instrument wear and tear, your storage, so many variables. So what you can do, you can calculate mean based on this analysis, what I said. You can calculate standard deviation from your past experience.
Okay.
Because this variation should not increase from lot to lot.
Correct. Okay, sir.
Whatever I'm telling you, this statement which I'm quoting, you can use standard deviation of previous lot. This
Acha.
mentioned in, what is that? There is a book by Todd and Stanford, by John Henry. So you
Okay.
refer to that in
Okay, sir.
that in the quality chapter they have mentioned. You can use standard deviation of previous lot because this standard deviation should not vary from lot to lot.
Yes,
Right?
sir. Okay, sir. Okay,
This will solve your problem.
okay, sir.
What
So
is
another small query.
Yes.
Suppose, you said, like madam, if we start that parallel QC testing and lot, that is, if that will be our documented procedure for setting the new QC lot. And as you mentioned, for some reason, we are getting our QC lot very late. So do we have to have a contingency documentation that in case such thing happens, then this will be our QC procedure to set the, lab mean procedure? Or we should follow whatever it is, the parallel lot to lot testing only?
No. One thing is, if suppose you are receiving control very late, as she said, then our approach is this: we will calculate our own mean, our own estimate. But suppose we are receiving supply very late. So in that case, for first month, we will follow manufacturer mean and SD. Then, based on that, we will start calculating our mean and SD.
Okay, sir. Sure, sir. Okay. Thank you, sir.
It should be well documented so that it is clear to people working in the laboratory.
Okay, sir. Okay, sir.
Yes, Dr. Gaurav Sharma, would you like to say something in this? You have a lot of experience related to this control and accreditation.
Can you hear me, Dr. Jain?
Yes, Dr. Gaurav, you are audible. First, introduce yourself, and then we would like to have your opinion in this.
Okay. So like Dr. Jain, I'm a graduate from University College of Medical Sciences in Delhi. And then I came over to the US, did my residency and fellowship training. I'm board certified in anatomical and clinical pathology, molecular genetic pathology, and informatics. I work as a regional lab director for a large healthcare system in Michigan. And I deal with the same problems that we were all discussing a few minutes back. And I'm delighted to be a part of this conversation. And I do like the point that in pathology, it's not very hard and fast about statistics. What we need to be thinking about is whatever you want to do in the lab, think about it, write it down, and have a procedure. And when our teams go for accreditation, the first thing we ask them is, okay, what is your contingency planning? And if you had a contingency, just show me you followed your own procedure. I think something that I've learned with the CAP is that they are not very prescriptive of what people need to do, as long as they are doing what they wrote down in their own procedure. But it's not surprising how many times labs will deviate from their own procedure. So that discussion was very enlightening. Anything else from my side, Dr. Jain?
Thank you. Thank you. Okay, what Dr. Gaurav Sharma said, if suppose there is some problem, either there is some deficiency in the procedure or there is deficiency in the implementation. And most of the time what happens, they are not much concerned about deficiency in the procedure if it is not significant. They are more concerned people shall follow the procedure, whatever they have documented. So they are not saying you have to follow manufacturer mean only in the first month, or you have to follow your own mean in the first month, or if you are saying we have calculated mean and SD based on our 6-day data or 7-day data, they are not concerned whether this is acceptable or not. They are saying it is okay. If you are providing us reference, this is acceptable. But whatever you are writing, you have to follow that procedure. If you are not following that, that is not acceptable. If suppose I am saying, in case of contingency, I will develop mean and SD based on my 7 days data. That is okay. You are saying you will calculate mean and SD based on your 10-day data. So if you are saying you will do this based on your 10 days data, then for you this 7 days is not acceptable. Because you yourself is documenting, you will use at least 10-day data. So this is what we have to understand. And that is why we are discussing all these things. And it is not only in India, people are facing problem. People are facing problem all across the globe. And the problem is these things are not documented properly in any single textbook. So all these things we learn by practice. This CLSI document A104, this is a very good document. There is one EP23, statistical process control, risk management based on statistical process control. That is again very good document. But problem is, one thing is to develop understanding after reading this book. Second thing is availability of these books. These single CLSI documents, these are costing around 10 to 12,000 rupees. So these are not easily available. And different textbooks One thing is availability of all those references. Second thing is understanding after reading them. And third thing is, after reading, ability to get the message imbibed in that particular sentence, whatever the textbook is writing. Then communicating to laboratory people, whatever you are reading, in a manner they are able to understand. There's so many things which we have to see. Yes, Karuna Veer, please unmute yourself. Good morning, Karuna.
Yes.
First, introduce yourself. Please
Yes.
use this background noise.
Sir, I'm able to hear you properly, sir.
You are?
Hello, sir.
Yes, Karuna.
Hello.
Yes, Karuna, please.
Yes.
Yes, Karuna.
Yes, sir.
You were writing some question in the chat box.
Yes, sir. I was just asking which document to refer for this calculate these things. This all the time we can.
I have few CLSI documents, and you can read this Henry and this textbook of microchemistry by Tits, or this chapter on quality in the ACM Lewis also, right?
So one you told that A104.
Yeah.
Hello. Yes, sir. Yes, sir. And the second one is by textbook of biochemistry treats, no, sir?
Yeah, right.
Okay, thank you.
Keep yourself muted. There is a lot of noise. Keep yourself muted. Yes. Right. The mean is very useful, but mean has certain limitations. If suppose there are 3 laboratories, one laboratory is saying my 3-day control results are for glucose 99.5, 100 and 100.5. Second laboratory is saying my results are 98, 100 and 102. Third laboratory is saying my results on the same control, they are 95, 100 and 105. Which laboratory has the best performance? You will say, obviously, the first laboratory, which is showing minimum variation. Although mean is 100 in all 3 laboratories. Yes, you're right. First laboratory has the best results. But based on these 3 results, it is easy to say which laboratory has the best results. But if we have monthly data, then how you will comment on this? You cannot say anything just by looking at the data. For this, you need some statistical tool. These statistical formulas are called statistical tool. What is that tool? Standard deviation. Now, look at this. Don't go by the complexity of this formula. All these things are provided to us by our machines these days, or we can use calculator or Excel sheet. What is more important? Understanding of the concept. Look at this, x minus x bar. Difference between mean and individual data point. Higher the difference, higher will be the square. This sigma means sum of square. Higher will be the sum of squares. As we have provided you one example of 20 data points. Higher the difference, higher will be the square of this difference, and then higher will be the sum of square. And if you are calculating square root, you will get high value for standard deviation. High standard deviation means high variation and less precision. Low standard deviation means low variation and low standard deviation means low variation and high precision. So that means standard deviation is telling us about precision. And sometimes we use n, sometimes we use n minus 1. What is the difference? If our mean value is calculated from the data only, then we use n minus 1. If we are using some external mean, then it is n. If suppose I am providing one reference material to you as a control sample, and I am saying in this material mean is 100, then you don't have to calculate the mean. Now you have mean provided to you. You are not calculating from the data. So in that case, in this calculation, you will use n. But if you are calculating mean based on your observations, then you will use n minus 1. This is statistical concept. So statistics and this standard deviation is telling us about variation, that means precision, but it has certain limitation. If suppose standard deviation in case of cholesterol is 10 and the mean value 200, and standard deviation in case of uric acid 1 and the mean value 5, where the variation is more? In case of cholesterol or in case of uric acid? If you will compare numbers 10 and 1, so you will say definitely variation is more in case of cholesterol. But you have to understand, there is variation of 10 out of 200 and there is variation of 1 out of 5. Key values are close to 5 in the one situation and you are getting this standard deviation 1. The variation is more in case of uric acid. If you will think logically, so what you can do, you can develop some statistical tool to compare data of different ranges which you are observing in different analytes. So for this you must have seen accreditation bodies, they also ask for CV % rather than SD, because with CV they can see variation in different analytes. And when you are submitting your CV, submit only up to 1 decimal point, because only that much variation they want to see. Because your computer, your calculator will give you CV 6.38296 or 5.4332. So that much is not required. 6.1, 5.3, 4.7, that way. Even if it is 6%, right? 6.0. It is clear you have defined up to one significant number. So that way you have to express your CV %. And remember one thing, from IQC you are getting information about the precision. You are running the same sample daily and you are checking variation. From EQUAS you are getting information about the accuracy. How much variation you are observing from the true value. This is called trueness of measurement. This is also called bias in your measurement. Trueness or bias, it is the same thing. And sometimes people they are a little confused when we are participating in IQC and we are getting good result. What is the need of EQUAS? This is the need of the EQUAS. We get information about accuracy. And from IQC, you are getting precision. And this understanding is important. Yes, Preeti Kumari, please unmute yourself. Dr. Sindhu George, please unmute yourself. Yes, Dr. Sindhu George.
Yes, sir.
Is it clear?
Yes, sir. Yes.
Because this understanding is very important. See, otherwise what may happen if you see this from your day-to-day life experience. Where are you from, Dr. Sindhu?
I'm from Kerala, sir.
Kerala. Which city?
Thrissur.
Thrissur, close to Cochin.
Yes, sir.
So are you in some medical college there?
No, sir. I'm working in DDRC laboratory, SR lab.
Okay, right. Good. Now see, if suppose I ask you, which is the big city close to your Thrissur, what will be your answer?
So, Thrissur itself is the city.
No, Thrissur itself is a big city. I agree. But suppose if I ask what is the major
Okay, Ernakulam, Cochin.
Kochi, right?
Yeah.
So in this, your answer is accurate, right?
Okay. Okay.
If suppose you are saying Kochi is close to Thrissur, you are saying 4 times, so your answer is accurate as well as precise. There is precision as well as accuracy, right?
Yes, sir.
If suppose you are saying 10 times, your
Okay.
Thrissur is close to Mumbai. This is not accurate,
Yes, sir.
but there is precision. 10 times you are saying this is close to Mumbai. So your answer is same. So your answer is not changing, but it is
Yes.
not correct. So you
Okay.
can get precision without accuracy, but you cannot get accuracy without precision. Right?
Oh, yes, sir.
Understand? And both are important. Right. Sometimes people say how many controls we have to run, how frequently. It is decided based on your workload, based on distribution of your work. 2 laboratories, they are receiving samples, 600 samples per day. 1 laboratory is receiving 600 samples in the morning time, and they are finishing all their tests by 2 o'clock. Another laboratory, they are running 24 hours. They are running these 600 samples over these 24 hours. And suppose there are 4 laboratories which are receiving 600 samples over 24 hours. Some laboratory they are receiving 300 samples in the first 8 hours, and then their distribution is scattered, or in second laboratory distribution is scattered for 24 hours. Third laboratory they are receiving more samples during night time. Then Dr. Santhil, please unmute yourself.
Sir, good morning, sir.
Good morning. Where are you from?
I'm from Coimbatore, sir, ESI Medical College.
From?
ESI Medical College, Coimbatore, sir. I'm MD Pathology, sir. Pathology.
What is the name of your city?
Coimbatore, sir.
Coimbatore. Okay.
Yes, sir.
Now, you are pathologist. What is your opinion? same system of quality control will work for all the laboratories, or they have to define quality control system according to their need.
Actually, according to the sample load, how to decide, sir, whether it's 1 run
Yes.
or 2 run.
Hmm.
That's my answer, sir.
Right. Okay. So one thing is you have to fulfill the requirement of accreditation body if you're going for accreditation. And second thing is you have to ensure quality of release result. For this, you have to see how you are running control. What is the intention behind running control? You want to detect an error before it is reflected in the patient sample. So this depends on your workload and this depends on your distribution of work. How the work is distributed. That way you are defining your IQC. Sometimes people say we will plot Levin-Jennings chart and we will follow Westgard rules. Sometimes people say we will follow Six Sigma. How we can use this, that we will see, because what is the intention behind running these controls? We want to detect an error before it is reflected in the patient sample. And now we have mean with us, we have SD with us, we have CV with us, but still we don't know whether the result on a particular day is acceptable or not. For this IQC, what is required? You shall have a documented procedure. How you will manage IQC in your laboratory? What is the requirement of your laboratory? Then, as Dr. Gaurav Sharma rightly said, it should be implemented in the correct way. Whatever you have documented, implement according to that. There shall not be any variation between implementation and documentation. Then, whatever data you are generating, carefully evaluate your data daily. And whenever you are finding something which is not acceptable, do the root cause analysis and take appropriate action. And document your action also. And monitor your action for its effectiveness. Then it should not occur again. If it is happening again, that means if it is happening, that means corrective action taken by you is not effective. You have to modify your corrective action. And metrics should be similar. Metrics, can anybody tell me what is metrics? What is metrics? Bushra server, please unmute yourself. Yes, Bushra, am I audible? We are not able to hear you, Bushra server. Amresh Pati, please unmute yourself.
Yes, sir.
Amresh, first introduce yourself.
Sir, I am a final year junior resident from AIMS Bhubaneswar, sir.
Okay. And what is
doing MD microbiology, sir.
MD microbiology. Okay. Can you tell me what is metrics? See, it is the, you can say, composition of material. For glucose in serum or in plasma, everything present in the serum or plasma constitute matrix for the glucose. Are you getting my point? If suppose you want to measure TLC, everything except TLC will constitute matrix. Sometimes when the sample is highly lipemic, you get pseudoleukocytosis. Where is the change? In the environment of that sample. Change is in the matrix. When we are estimating some analyte, we are using some material as control. It should not be it is in the deionized water. It should be in that particular matrix only. These type of controls are provided to us by our manufacturers or some other independent control producers. So now we discussed this mean SDCV. They are not sufficient to decide whether result on a particular day is acceptable or not. So what we need to do? We need to develop Levy and Jennings charts. These charts were first described by Dr. Schwartz in 1930s. Levy and Jennings described their use for the first time in medical laboratory. So in medical laboratory, these charts are called Levy and Jennings charts. In all other industries, these are called Schwartz charts or QC charts. In this, we draw two lines perpendicular to each other. Again, these charts are provided to us by our machines. What is required? A good understanding at our level. At the point of intersection, horizontal and vertical line, we write mean. Above that, 1 SD, 2 SD, 3 SD. Below that, minus 1 SD, minus 2 SD, minus 3 SD. And on horizontal line, we write number of observations. What I mean to say, suppose mean value is 100. Standard deviation is 2. And we are running 2-level control daily. At the point of intersection, we will write 100, which is mean. 1 SD means 100 plus 2, 102. 2 SD means 100 plus 4, 104. 3 SD means 100 plus 6, 106. Because we are assuming SD is 2 and mean is 100. Similarly, on the lower side, minus 1 SD means 100 minus 2, 98. 100 minus 4, 96. 100 minus 6, 94. And on the horizontal line, we are writing number of observations. We are running 2-level control daily. 1 morning, 1 evening, 2 morning, 2 evening, 3 morning, 3 evening, 4 morning, 4 evening. Like that, we are running control. For different analytes, we need different Levy and Jennings chart. For different level of control, we need different Levy and Jennings chart. If we are running same level of control multiple times, then we can use the same Levy and Jennings chart. Now suppose first day, the result is 101. We are putting point here, then 100, then 99, 99.5, 100.5, 100. And when these points are joined, this is called Levy and Jennings chart. Now we have this chart with us, but still our question is unanswered. How we will decide whether the result on a particular day is acceptable to us or it is not acceptable to us. So for this, we need some more information. What is that? Dr. James Westgard describes certain rules around 1970 to decide whether a result on a particular day is acceptable to us or it is not acceptable to us. He said, if one value is beyond 3 standard deviation, this lower diagram, if one value is beyond 3 standard deviation, this situation is not acceptable. It is showing significant variation compared to rest of the data. Suppose daily we were getting values close to 100, and on one day it is 93 or 107. That means something has happened. We have to see what has happened. Stop testing. Do the root cause analysis. Take appropriate action. After that, run control. If this control result is within acceptable limit, that means whatever problem was there in the beginning, we have sorted out that problem. So now, otherwise, whatever we are getting in these controls, same thing may happen to our patient result also, which is not acceptable. And also remember, whatever you are getting, this 1,3S, or we will discuss some more examples. These values, they are only guiding us. Okay, there is some problem, take appropriate action. In the monthly mean and SD, use only that value which you are accepting after corrective action. If you will use this value, this will widen your standard deviation because it is showing more variation. Next month, you may accept some result which should have been rejected, or it may deviate your mean. We have to remember these are only guiding us in the calculation of our monthly mean. In the calculation of our monthly SD, we are using only accepted values. Now suppose one value is beyond 2 standard deviation. 1/2S means one value beyond 2 standard deviation, but less than 3. They say, for once you can accept this, but carefully watch next cycle. If it is again showing variation more than 2 standard deviation, that means something has happened which has started affecting our all results. Previously it was more than 2 standard deviation. Now also it is more than 2 standard deviation. Tomorrow also it may be more than 2 standard deviation. We have to see what has happened. Don't run patient sample, stop testing, do the root cause analysis, take appropriate action, after that run control again, and reject both of these values in the calculation of your monthly mean and SD. Use only that accepted value. This understanding is very important of statistical concepts. These calculations are provided to you by your machines. We discuss certain formulas and that graph for our understanding. What is more important? Which variation is significant? We have to detect that. If suppose in another situation, one value was on the lower side of 2 standard deviation, and next day value is on higher side of 2 standard deviation. If suppose both are in acceptable limit, but it is showing variation almost 4 standard deviation. Why we are getting this much variation in our data? Document this, do the root cause analysis, take appropriate action. What is the reason? Maybe some random error, some electronic fluctuation, or some bubble in the aspiration. We have to find out. If results are not showing significant variation, but multiple values on one side of the mean, that means something has happened which has started affecting our all results. Stop testing, do the root cause analysis, take appropriate action. Sometimes what happens, we get multiple values which are slightly away from the mean, but on one side of the mean only. Many times less than 1 standard deviation. And the most common reason for this is lab is not calculating their mean. They are following manufacturer mean. Whatever deviation they are observing based on so much variables, they're receiving all results on one side of the mean. If they will calculate their own mean, then this problem get rectified. And you may be wondering, what is the best way of this troubleshooting? If this is the situation, what will be the best action for me? If this is the situation, what is the best action for me? See, one thing is, stop testing first and identify this out of control situation. And recalibration is not the solution. This will add to your problem. Or running control again, that is also not the solution. What is important? We have to identify problem first. And this statistical calculation which we are discussing, these are related to our quantitative results. We face problem in our histopathology also, cytopathology also, so much variation in the opinion of different people, but there we cannot apply all these things. There the system is different. Here we are discussing statistics, this applies to quantitative. So first we have to understand the problem. We have to review Levin-Jennings charts. We have to see what is the error and what are the possibilities of these errors. Root cause analysis, corrective action, and documentation is very important. First, we have to understand the problem, only then we can solve the problem. So for this, a good understanding of the concept and good implementation of the concept in a situation is important. So for this, what is required? We have to see our Levin-Jennings charts and QC multiple rules. Okay. What are the rules which are not being complied in a particular situation? Don't reject based on 1-2s, then your rejection rate will be very high. If it is not serving any purpose and you're rejecting so many values, then what will happen? Unnecessary wastage of reagent, unnecessary wastage of control. This will add to your cost and your turnaround time may also be affected by that. If a single value is showing variation more than 3 standard deviation or random value more than 4 standard deviation and you're doing root cause analysis, you're not finding anything, and when we are documenting everything and you're running control again, that control result is within acceptable limit. That means some random error, as I said, electronic fluctuation or some bubble. But if it is affecting multiple results, 2-2s or 4-1s or 10x, which we discussed, that means systematic error. Something is there which is affecting our all results. So we have to identify whether it is random error or systematic error. Then we have to identify what are the reasons for these. So for this, what is required? A good understanding of identifying problem in the QC, this Levin-Jennings chart is important. Systematic error means values are significantly away from the true value. This is called trueness or bias. And these days we are using this term trueness more often. And when there is systematic change, one thing is gradual trend. Sometimes what happens, if suppose we are getting results near the mean, and suppose we have reconstituted a control material today, and then we are running, we are now getting some different value than the previous value. That is okay, every time value will be little different. But suppose it is little lower, and then we start getting values close to that lower value. We are getting change, sometimes higher value, lower value, but all these values are lower than the previous value. That means there is a shift from higher to lower, and then that lower is maintained. This is called shift. But when it is moving in one direction, either higher side or lower side, then it is called trend. So we have to understand this. And when we talk about inaccuracy, so both of these operate in that inaccuracy. So this is what I wanted to show. This is not a good example of telling you the trend or shift. This is, you can say, this difference between two red dots, this is only a significant variation. You can say some R4S type of situation, some random error. But look at this, red dots. It is showing trend. It is moving in one direction. Below this, in the beginning, these green dots, they are increasing. This is called trend. After that, two values close to that higher values, and suddenly there is a drop. And then this drop is maintained for 5-6 values. And again it is showing trend. And then that trend is, that higher values are maintained. So this is what is called as trend. This is shift. Then this is again trend. This we have to understand. And we also have to understand what is the reason of this trend, what is the reason of this shift. When you will start thinking in these terms, our understanding will improve. This is also not a very good example. Why I am showing you these different graphs, these different charts, you will get better understanding what exactly we want to say. Now see here, the difference is increasing, but not very significant. But all these values are on one side of the mean. You can say this is a trend. We are getting all values on one side of the mean. Only this much you can say. Whether this is continuously increasing or not increasing, it is very difficult to comment on that. But one thing is clear, these are definitely on one side of the mean. Here, there is a drop, and then it is moving in more direction. So this is called shift. Although very little shift, but definitely there is a shift. So we have to see whether this shift is acceptable or not. This is significant or not. This we have to understand. This shift and trend shows systematic errors. Either gradual change in one direction, that is called trend, or sudden change and then that change is maintained, that is called shift. Whatever is there, it may be related to reagent, it may be related to instrument. If there is shift, if suppose there is change in lot, this change in, you have reconstituted some new reagent, a new control material, or you have calibrated your machine, these may be the reason. Problem may be related to your calibrator, or it is not a problem. Previously there was a problem, now it is only showing shift. Problem may be related to instrument, or rather than word problem, you can say reason may be related to instrument. Preventive maintenance or lamp recalibration, some sampling related, or temperature or water quality related, trend, control deterioration, instability, or some shift in the, some change in the calibration, random errors, bubbles while pipetting, or improper mixing of material, fluctuation in temperature, or operator error. When there is any such error, we have to see from this perspective. Okay, these may be the reason. When you will start thinking in these terms, you will be able to find some problem. And when you're finding some problem, first thing is identification, and then root cause analysis is very important. You shall have a lot of questions in your mind. When you will start thinking about answers of these questions, you will discuss with your company people, you will discuss with your colleague, you will discuss with other laboratories, you will be able to find some solution. Now, what is the best corrective action which is able to solve this problem? It is not happening again. This is also important. Again, I will emphasize on this point, documentation is very important. When you are thinking about the problem, think about one thing at one time, whether this can contribute to this problem or not. If some change is required, you are implementing that change and see for its effectiveness. Risk management. What is risk? Risk of issuing wrong report to the patient. You have to see whether this variation can cause variation in the patient result in a significant way or not, and how we can mitigate the possibility of this happening. For this, what is important? Whatever variation you are getting, whether it can result in incorrect result. Sometimes what happens, as some people, one person was pointing out, that sometimes our range is very narrow. Suppose range is very narrow in case of potassium. And in case, instead of 4.5, we are getting a result 4.4. And you're finding this as outlier. You're taking appropriate action. But when you're analyzing, you may find this is not affecting our patient result in a significant way. So there is no need of recalling patient result, because it is not resulting in incorrect result. And although I have identified this problem, But do this require detailed root cause analysis or any preventive action or corrective action in the situation? This also you have to see. Sometimes what happens, suppose you are running control and you are getting one problem today. You are not finding anything in root cause analysis. When you are running control again, everything is okay. That means probably it was a random error. Same thing is happening suppose after 2 months, and same thing is happening suppose after 4 months. Then you're considering this as random error. But suppose this thing is happening on a weekly basis, sometimes twice in a week, sometimes once in a 10 days, it is occurring very frequently. Then you cannot ignore this. That means there is some problem. Why this thing is happening? Even if it is bubble while pipetting, that means the person is careless. Many times he is facing this problem or some other problem, maybe some electronic fluctuation. That means that UPS is not working well. You are getting fluctuation very frequently. So we have to see. But whether you are getting some problem infrequently or frequently, documentation is very important, because this will help us to decide whether something is happening very frequently or not very frequently. So whenever there is any unacceptable event, see what is unique to this situation. Did our technician change the result, change the reagent, or reconstitute the reagent, or change in control lot, or reconstitution of control, or it is related to calibrator, or some recent maintenance has been performed on the machine which is related to some analytical part, or there is some part replacement, or change in the operator. Think from this perspective. Or if more than one chemistry affected, what is common to the situation? Whether these are the enzymes analyzed on the same filter, or one is enzyme, another is endpoint chemistry, or different enzymes or different endpoint chemistry, whether it is affecting single level of control or multiple level of control. This is also very important. If suppose both level of controls are affected, then it may be related to reagent, it may be related to calibration or some common factors. If only one single level of control is affected in a particular chemistry, then it may be related to that control material. Problem is related to your main instrument or backup instrument. You also see if it is affecting multiple chemistries, some common factor like environmental factor, that is your deionized water system, or maybe related to temperature, or you have received 4 reagents in a single shipment and all 4 these reagents are showing problem, or you have multiple refrigerators. In a particular refrigerator, you have stored these 4 reagents or 2 reagents, these are showing problem. So that way we have to develop a little Sherlock Holmes within us. And we have to see problem in this way, because you will not find these in any single book. If you know any single book, so please let me know also. Yes, Dr. Manjari Kishore.
Yes, sir.
Yes, Dr. Manjari, first introduce yourself.
Sir, myself, Dr. Manjari Kishore. I'm working as Assistant Professor Pathology in Noida International Institute of Medical Science from Pathology Department.
Okay. So, yes, Dr. Manjari, do you know any book
Yes, sir.
which you can use to learn all these things?
For the lab stats.
Obviously, we are discussing laboratory only. In this, they have provided statistics in detail related to laboratory and how to interpret. And if there is one situation, how to do the root cause analysis, what is the best action in that particular area. Do you know any book related to this?
Book as such, no, sir. Because if I encounter any kind of problem, then I like refer to like individual things. Not as I don't know. I won't remember any sort of standard book.
That means we learn all these things by experience.
Yes, sir.
Certain things discussing with our company people,
Or colleagues.
with our colleague, and we attend various conference, seminars, symposium, etc.
Yeah, yes, sir.
When we are working in our laboratory, we are facing some challenge, and we are trying to find out solution for that challenge. This is
The mistakes we do and the correction we apply. That is the best learning process.
right. Thank you.
Yes, sir.
Dr. Mithilesh, please introduce yourself.
Hello.
Please introduce yourself.
Sir, myself, Dr. Mithilesh Kumar Singh. I am the tutor in Noida International Institute of Medical Science, Greater Noida, Biochemistry Department, sir.
Oh, right. Thank you. And whenever you're facing any challenge, also see, is the machine showing some error message? If there is any error message, refer to your manual and see what is the interpretation of that error message. And also see whatever target ranges you are using, that is appropriate. Sometimes what happens, yes, Amanpreet, please unmute yourself.
Yes, sir.
Am I audible clearly?
Yes, sir.
Okay, right. Sometimes what happens, you have received the new lot and you're using that new lot. But by mistake, people are using old reference document, old comparison chart, and they are getting outlier. So this should not happen. And also discuss with your friends if they are also using the same control material, what is the mean you are getting, what is the mean they are getting, there is any change in the manufacturer instruction. So all these things are important to take appropriate action in a situation, and with time we build up our knowledge related to this control material. Right, so now we will have a, see, whenever there is out of control situation, what we have to do, we have to see where this problem can happen. This may be related to your control material. This may be related to reagents or calibrator or instrument or may be related to environment. Add one more thing in this, it may be related to your operator. In the control material, you have to see this is the correct material. Means if suppose you have 2-3 level of control, so whatever you are using, it is of the correct level. Sometimes what happens, people are using some control and they are evaluating based on some other comparison chart. That should not happen. And it has not been expired. You are storing control under defined conditions. You are storing properly. When you are reconstituting, you are reconstituting this control properly. And when you are running a control, you are bringing this to room temperature. After bringing this to room temperature, you are keeping that Eppendorf tube open, run promptly. Otherwise, what may happen, some part of that control will get evaporated. When this will get evaporated, what may happen, you will get higher results. You have to see all these things. Whenever you are getting a normal result, it is not necessary that this is related to calibration or this is related to some poor quality control. All these things we have to see. An additional thing, sometimes what may happen when you are running control, you are preparing suppose 10 aliquots. For 4-5 aliquots, you are getting appropriate result. Then you start getting some trend. The results are lower than the expected and they are moving in one direction. Yes, Anil Puriji, please unmute yourself.
Hello, good morning. Good morning, Dr. Jain.
First introduce yourself, then.
I am Dr. Anil Puri. I am from Amritsar. I am running my own lab, Dr. Puri Lab, and I retired as a teacher from the Government Medical College of Amritsar.
What is your Dr. Puri?
Yes. Hello.
What is your specialty? Pathology,
I am pathologist.
You are pathologist. Okay. So when you are running control, you must have faced sometime this situation. For 4-5 days results are okay, then they start going in one direction.
Yes.
So now we have to see what is the reason of this. Dr. Sindhu George, please unmute yourself. Jaspreet, iPhone.
Yes, sir.
Jaspreet, first
Good afternoon, sir.
Good afternoon.
Sir, I'm Dr. Jaspreet. I'm professor in biochemistry in Noida International Institute of Medical Sciences.
Okay, very good. Okay, did you ever face this type of problem?
Yes, sir. It has happened when there was improper storage, actually. We had some temperature fluctuation in the refrigerator. So
that means it is very important to control all these things. And sometimes what happens, suppose you are reconstituting some control material and you are preparing 10 aliquots. For 4-5 days, the results are okay. Then it starts showing some trend. Right, Jaspreet?
Yes, sir.
Then what is the reason? And if you are evaluating properly, then you are finding the person who is running these controls, person take out the complete box and
Yes.
keep that complete box at room temperature. Or even if it is not keeping that at room temperature, daily they are taking out box, they are taking out one control and then then keeping that again in the deep refrigeration. But there is some disturbance in the temperature daily.
Yes.
So now when you're finding this situation, what you can do, you can divide these 10 liquids in two small boxes. So for first 5 days, you are bringing a liquid from only one box, and that
Yes.
from the refrigerator only. You are not taking out that box, and that rest of the 5 controls, these are not disturbed at all. After 5 days, then you are taking out control from the second box. So then
Right.
your storage will be better, right?
Yes.
So what
Yes.
I mean to say, and all these things, I don't know, you are from the biochemistry.
Yes, sir.
So did you find all these things in any textbook of biochemistry?
Not at all, sir. This comes with
All
experience.
this we
Definitely.
learn by experience, and all this we learn by sharing experience.
Definitely,
Certain
sir.
things I'm sharing with you, certain things you are sharing with me. All these things we learn by experience. But all these things are important. So that way, we have to learn and we have to develop our knowledge. When you will start working in this way, because if you are going for accreditation, ISO 15189 is one thing. ISO 15189 is a standard. How you will fulfill the requirement of accreditation. But all these things, these are our day-to-day activities. How we will carry out so that we are able to meet the requirement of ISO 15189. We are also able to meet the requirement of our laboratory, of our clinician, of our patients. Then reagents, whatever reagent we are using, this is a correct reagent. Placed in the correct position. It is not like that in the place of cholesterol, somebody by mistake has placed uric acid. You will not get the correct result. If it is new reagent, lot acceptance testing has been performed. New lot, you have performed lot acceptance and it was okay. It is stored properly under defined conditions. If need to be reconstituted, it is reconstituted properly. No bubbles etc. are there, because if these bubbles will get aspirated by that probe, you will get, what will happen? Less reagent, correct control you will get. Because of this less reagent, the ratio will get disturbed, you will get higher results. It is not expired. And as I said, you have completed lot acceptance testing and you have correct documentation of that lot acceptance testing. What is the clause related to this lot acceptance testing? 5.3.2.3. Same is true for your calibrator. It is reconstituted properly, stored properly. It has not been expired. And what you can do, when you are storing this control, you can store after preparing aliquots. And sometimes what happens, after storing, if suppose this you don't require calibration very soon, sometimes this calibrator material, this get spoiled. or get expired, what you can do, you develop a system in your laboratory, develop a schedule, and you're saying we will run this calibrator as a sample, and we will see what is the value written on that calibrator and how much we are getting. If suppose you are getting significantly lower or higher value, there is problem in the accuracy. And these days, we have accuracy controls also. So you can use this calibrator material as accuracy control and you can check variation. If this variation, whatever you're defining, is more than that, that is, it is significant, then do the root cause analysis. And if it is required, you can use this to develop your calibration schedule. Whenever it is showing more than this variation, there is no other factor responsible, we will recalibrate. Maintenance of the instrument is very important. You shall have a clear understanding what need to be maintained on a daily basis, what need to be maintained on a weekly basis, monthly basis, once in while you are calling company engineer for the maintenance. And also examine your machine visually. There are no leaks, or in probe there is no proteinaceous deposit which is very obvious, or see this everything is proper as per the requirement. And if it has some monitor, status monitor, it is perfect, it is not showing some abnormal message. Environmental conditions, temperature is maintained properly in the defined range. If suppose you are saying you will maintain temperature between 20 to 23, you are following that it is being maintained in that range and you are recording temperature. This is requirement of your standard also, 15189. If you are going for accreditation, clause 5.2.6, you are checking pH and resistivity of deionized water. Everything is okay. Then air quality is okay. There is no excess CO2 or alcohol fumes. Then operator shall have qualification related to his or her activity, shall be trained to operate that machine, shall have training from the company people or some other person is training him or her. Person shall have training related to SOP, what are tests the person is performing, and also person is running controls. The person shall have understanding of your IQC procedures, which you have developed as per the requirement of clause 5.6. Person shall have understanding of EQUAS procedure, which you have developed, and shall also have knowledge related to levy engineering charts and West Guard rules. And whenever there is any outlier, that person is reporting to authorized signatory, discussing with him. This is the situation. And the person can review old documents. We face this type of situation 3 months back also. And I have read what was the action taken that time, what was the root cause analysis that time. And after that, I have taken this decision. That way, they will develop their knowledge and they will decrease the burden on authorized signatory. And ultimately, this is a happy situation for the laboratory. People are competent to carry out their work. Now we have checked everything. We detected problem. We checked our control material, we checked our calibrator, we checked our reagent, we checked our instrument hardware, we checked environmental condition. We have also checked requirements related to operator. But sometimes still there is no identifiable cause. But definitely there is out of control situation. We have analyzed control again. This is okay. Probably this is a random error. For this, no corrective action is required. But see, you have to be very watchful. Okay, this is not happening very frequently. Now, problem is solved. But what is important? Documentation. And also see what all results you have released after the last successful QC and whether you need to repeat those tests or not. Is it showing significant variation? If it is showing significant variation, then you have to take appropriate action. You are recalling and informing the new result if it is showing significant variation. So now, what is important? Perform this QC according to your SOP. Whatever procedure you have developed, follow that. Troubleshoot in a structured manner, as we discussed, and do not report patient result unless the QC for that test is correct. As we discussed in the beginning, automatically we are running QC or calibrating. That is also not the solution. An important thing is documentation is very important. This helps us in developing our knowledge. We discussed these controls. But in hematology, situation is little difficult. Stability of the control is less. We face a lot of problem. What we can do? Yes, Rashmi Shetty, please unmute yourself. Risha, please unmute yourself. Risha Shetty, any Rashmi Shetty, Preeti Kumari. Preeti Kumari. Mohammad Zarif.
Yes, sir. Good afternoon, sir.
Zarif. Introduce yourself.
Hello.
Zarif, first introduce yourself.
I am Dr. Zarif, working in Saudi Arabia as a pathologist.
Okay. Now, Zarif, what is your opinion about hematology control? Are you facing any problem related to interpretation of results of this hematology controls? Can you plot Levin Jennings chart for this hematology control?
Yes, we are using moving control also, moving average for the hematology. And the problem we are facing the stability, as you said, because sometimes the control is sudden, out of range. So that is we are facing this stability control, but we are trying to control this stability by monitoring the temperature or for the control. But that is the problem we have, this stability.
Everybody is facing problems related to hematology control all across the globe. Problem is stability of the controls is very less, 14 days or 21 days. And suppose lot is changing after 21 days, then we cannot use mean or SD, which we have calculated earlier. So when we cannot use previous mean or SD, so we cannot plot Levin-Jennings chart. And in the data, they are providing us mean. With that mean, upper level of comparison, lower level of comparison, they are not providing us standard deviation. So we cannot plot Levin-Jennings chart. But what we can do, as we discussed earlier also, with controls, we want to check precision. We have mean value. So our result should not be significantly away from the mean value. So that way we are checking about accuracy. And whatever CV percent we are calculating based on this 21 days data, or we are running to level, we are running control twice a day. If stability is 14 days, we are receiving 28 data points. If stability is 21 days, we are receiving 42 data points. We can calculate CV. And we can compare CV of different lot, because with lot, variation should not increase. So we can have a data chart of CV percent comparison of different figures: hemoglobin, TLC, RBC, MCV, MCH, MCHC. So we can see it is not deviating significantly over a period of time. So this is what we can do in hematology. Because generally what happens, most of the time laboratories, they calculate mean and SD based on 21 days data, and then they use same mean SD to plot the Levin-Jennings chart of the same data from which they have calculated mean and SD. Now what happens sometimes, suppose on 30th of August today, you are finding RBC count on 16th of August was not acceptable. It was lower than the expected value. Now, how you will take the corrective action? Now it is not possible. That exercise has no value. But based on 21 days data, if you are checking, you are comparing daily results with the mean value, and if suppose one day it is showing significant variation, so you can find out at that time only. And if monthly CV is fluctuating for one particular light, you are finding more variation, then you can see, you can call company engineer, because otherwise also hematology analyzer variation, you need to call company engineer. You cannot do any activity on your own, and even for the calibration also, you have to call company engineer. Now for differential count, what happens? We are getting differential in percentages as well as absolute value. So when you are calculating variation in your differential count based on control data, use absolute values rather than percentages, because first you are getting the percentage, then you are calculating again the percentage only from that percentage. Better way is you see how much variation your machine is producing in identifying a type of cell. When you are using the same control material, whatever absolute value you are getting daily for neutrophils, for lymphocytes, for monocytes, you see how much variation you are getting in that. They use absolute values in the calculation of percentage variation. How this EQUAS scheme is interpreted? One is Z-score, if it is quantitative EQUAS. This is also known as Standard Deviation Index, SDI. Some EQUAS providers, they use this term SDI. Some use this term Z-score. Both are okay. In qualitative EQUAS, we compare with the peer group. Or EQUAS providers, they provide us some criteria. So if they follow some criteria, they tell us whether our report is acceptable or not. Most of the time what they do, they say, in case of qualitative EQUAS, more than 75% participants shall have concordance in results. If suppose it is EQUAS was put on for AFB. If 90% are saying AFB is positive, 10% they are saying AFB is negative, the possibility is those 10% are not correct. But if 60% are saying positive, 40% are saying negative, then that material has some problem. You have to reject that cycle. This we have to understand. And participation in EQUAS, this is a requirement of ISO 15189. Laboratory shall have a documented procedure. In this, you are defining responsibilities, who will run this sample, and participation in the EQUAS is mandatory if some national program is available. If some national program is not available, you can have alternate approaches, like you are exchanging sample with other laboratory and define your acceptability criteria. You are performing split testing, dividing sample into 3 portions and asking your staff to perform test, and then you are comparing results. You are comparing variation in their observations. Or you can provide some reference material to them and you can see. Then important thing is this EQUAS sample shall not have any special importance, and the person who is performing patient results as a routine, that person only shall perform test on this EQUAS sample. It is not like that some special person will perform tests. And results shall not be discussed with the other participants of that EQUAS scheme in other organizations. It is not like that you are organizing a kitty party and in that party you are deciding what results shall be submitted to the EQUAS provider. And you cannot refer these to your reference laboratory. Whatever result will come from them, that I will submit. No, that is not correct. And you shall have a predefined performance evaluation criteria, maybe Z-score or something else. And whenever you're finding this predefined criteria is not met, you are discussing with your colleagues, discussing with your lab people, And after root cause analysis, taking appropriate action. And you're monitoring the effectiveness of this corrective action. The next cycle, that problem shall not happen again. And if this analysis you're finding some trend, although result is acceptable, but over a period of time you're finding some trend, then you're taking appropriate preventive action. What is Z-score? It is used to evaluate a class result, quantitative class result in a scheme between -2 to +2 acceptable, 2 to 3 or -2 to -3 warning signal, less than -3 or more than 3 action signal. One action signal or two consecutive warning signal indicates intervention. And how this Z-score is calculated? Assigned value. What is the value assigned to this QC material? Most of the time it is group mean, and it is provided to you in the report. This group mean is subtracted from the patient result, from the lab result on that equus sample, divided by standard deviation which equus provider has observed in the data which that has received from different participants. So lab result minus assigned value, most of the cases the group mean only, divided by SD observed in that equus scheme. It is not the SD which you have observed in your laboratory in IQC. It is the SD observed by equus provider in the equus scheme. And this is also provided to us in the report. Now we have to understand what is the use of knowing this calculation. Riti Kumari, please unmute yourself. Yes, Jasprit, please unmute yourself.
Yes, sir.
Jasprit, what is the importance or what is the benefit of knowing this calculation for us? Because the Z-score is already provided to us by the manufacturer. We know if it is more than 3, we have to take action.
Yes, sir.
If it is 2 to 3, then we have to monitor in the next cycle. If it is less than 2, this is acceptable. So what is the importance of doing this calculation?
So we can go for root cause analysis and we can judge our results.
How?
Sir, by watching the standard deviation.
See, see.
Like the lab result is being.
Tell me one thing. If
yes, sir.
Your lab result is 108 and group
yes, sir.
and standard deviation is 2. Manufacturer is
so lab result is
provider is telling you your Z score is 4. If it is more than 3, you have to take action. Whether you know this calculation or you don't know this calculation. So what is the importance of knowing this calculation for you? This is what I wanted to understand.
So if our standard deviation is falling above or below 2, then we can.
But this is the standard deviation which people they have observed. This is not calculated by you.
Yes, sir.
It is calculated by class provider. Suppose
right, sir.
Aware of this formula. Then what is the disadvantage with you? Or if you are aware of this formula, what is the advantage with you? This is what I want to know. You know Z
Sir, the environmental factors or any other discrepancies which it may be unnoticed by us, we could.
how this formula will help you in deciding that?
Because this factor is not being subtracted by other labs, like
But
standard deviation.
subtracting that, this is the Z score provided to us by the manufacturer.
Yes, sir.
Now, Mother, I want to understand whether you have this concept or not. What is the importance of knowing this formula? Because this understanding is very important. One thing is knowing a concept.
Sir,
Second,
sir, one standard deviation is because according to our lab, one standard deviation is the one given by the EQUAS provider. So that environmental conditions are not availing in other labs. So that may be the contributory factor. I mean,
this standard, this whatever environmental condition you are saying, that is okay. That you are
yes, sir.
is the cause of error. But how this formula will help you in deciding that? If temperature is for 4 days, it is 26, or on the day of running EQUAS is 26, which is not acceptable. So you are
yes, sir.
Suppose Z score 4.
Yes, sir.
So Z score 4, when you are evaluating, you are finding temperature was not correct.
Fine, sir.
How this formula is helping you in deciding that? That you are getting information from your temperature chart of lab.
Yes, sir.
I am asking, what is the use of this formula in your laboratory?
सर वो हम करेक्टिव एक्शन कर सकते हैं ना उसी टाइम
कैसे? वही तो मैं पूछ रहा हूँ, कैसे करोगे?
We will, sir, it will be a retrospective approach of ours, seeing and negativating the factors which we are finding.
रेट्रोस्पेक्टिव ही होगा ना, आपको पुराना डाटा देखना है, ऑपरेटर को देखना है, कंट्रोल को देखना है, कैलिब्रेटर को देखना है, को देखना, वो सब आपने उसमें आपको कोई एरर मिलती है। अब ये फार्मूला पता है या नहीं पता, इससे आपको क्या फर्क पड़ा?
Sir, I'm not able to answer it that way.
No problem, no problem.
Yes, sir.
Everything we learn, discussion only. तो why I am discussing in so much detail with you? अब जब मैं बताऊंगा ना, तो आप पॉइंट आप कभी नहीं भूलोगे, क्योंकि आपके साथ ही डिस्कस हुआ ये, आपका नाम बोल के, है ना? अदरवाइज जैसे ही बताया था, तो कई बार उस वक्त कोई चीज और कोई सामने आ जाए, कोई फोन आ जाए, तो कई बार दिमाग से वो चीज निकल जाती है। तो अब now you will not forget. Now, suppose the Z score is 4.
Yes, sir.
Lab result is 108. Group mean is 100. Standard deviation provided to you by the EQUAS provider is 2.
Yes, sir.
Whatever action you are taking after root cause analysis, you are taking that action.
Right, sir.
And if suppose there was some temperature problem, now you rectified that problem. Or
yes,
if there was some other problem, you have taken appropriate action. Now, whenever you are participating in EQUAS, you store that sample after preparing a records in the deep refrigerator.
Yes, sir.
After running that, now take out one record, bring that to room temperature, run that control again.
Okay.
Now you are running again, your lab result will change. Signed value will remain the same, whatever they have provided you. Standard deviation will remain the same, whatever they have provided you. Suppose now your result is 102. What is that score now? Now it is
now
1.
It will be 0.
Now it is 1. 102 minus 100 divided by 2, 2 divided by 2, 1. Right?
Right, sir.
Now it is in the acceptable range. So that means whatever problem you observed at that time, that problem is not existing now.
Yes, sir.
You have taken appropriate action, you document that, and you close that.
Right, sir.
Now suppose your result is again 108 only or 107. That means the score is still more than 3.
So we take out, we have to see another.
Whatever action you have taken, that is not sufficient.
Yes.
You have to expand your root cause analysis or what you are doing now, you have to find out whether the problem is related to the sample or in my analysis.
Right, sir.
You are sending a portion of sample to your referral lab for interlaboratory comparison.
Okay.
If suppose they are telling you their result is 102 or 103, so that means your analysis is showing higher result. So you have to see,
yes, sir.
all company engineer, or you have to see what is the fault I am facing in my analysis. If suppose that laboratory is saying my result is also 108 or 107, so that means there is no problem in your analysis. Problem is related to that sample.
Reconstitution of the sample can also be the problem.
Now, problem is related to sample. We have to find
Right.
what is the fault in that sample. Now you are calling that request provider. See, we have faced this problem. That person may say, yes, we have received similar complaint from some other participants also. There was problem in the storage of that reference, storage of that request sample in our laboratory, and you please reject that. We will issue you a letter in this regard.
Right.
It is clear that there is no problem in your analysis, so there is no action required at your level. And for that non-conformance in that request, you have documented evidence, the letter which you have received from the request provider. So during execution also you can show that. If suppose they are saying, no, we have not faced any such problem, nobody else has complained. So now you are finding who has reconstituted or what is the reason. So that way you can do the root cause analysis and document your action. So that is why this information is important for you, because based on your present result, you are recalculating Z score and you are finding whether this Z score is acceptable or not. Right?
Right, sir.
We have to do inter-equipment comparison. When we are buying a new equipment or equipment we are already using, suppose two equipment for biochemistry, whether results on both these machines are comparable or not. When we are buying a new equipment, that new equipment is showing results comparable to our old equipment or not. So at two places we do inter-equipment comparison. For new equipment, what is required? We calculate correlation coefficient, we do regression analysis. Now look at this picture. Suppose we want to analyze one hematology analyzer. On the x-axis, we are plotting results of our old machine, which we are using in our laboratory, and we are happy with this machine. Y-axis, our new machine. What is expected? If we are getting 5 gram per DL on our old machine, so it should be 5 only on our new machine. If we are getting 10 on old, it should be 10 on new. So that means we are expecting a line at 45 degrees. This is the ideal situation. But in life, we expect so many things, but we are not getting all those things. If this line is almost overlapping this ideal situation, still it is okay. But if it is consistently showing values higher than the expected, so this is, and it is at all range. This is systematic error. This difference is constant. This is called systematic constant error. If this difference is changing with increasing concentration, suppose it is decreasing, this difference is increasing with increasing concentration on the lower side, suppose. This is called proportional error and it is affecting all results. This is called systematic proportional error. So we have to document this. For this, what we do generally, we use calculator provided in the Westgard website. When we submit result of both the machines, it calculates one R2 value. This is called correlation coefficient. If it is more than 0.9, this is a good correlation. More than 0.95, excellent correlation. It should be close to 1. So what we can do, we can document this for biochemistry analyzer, for different analyze, for hematology analyzer, different parameters. And if we want to compare 3-4 machines, which machine is good for us, what we can do, we can plot this R2 values in a comparison sheet, and we can see B versus A, C versus A, D versus A. These are the different analytes, and we are getting more than say 0.95 R2 value for most of the parameters in this machine C. So that means this machine is good for us. If we are already using 2 machines, what we can do, whenever we are finding EQUAS sample, we can run EQUAS sample on both the machines. Data 1 machine we are submitting to our EQUAS provider, and they are providing us Z-score. For second machine, we can calculate Z-score ourselves. We are using the same assigned value and standard deviation, and in lab result, we are using the result of our second machine, and we are calculating Z-score. And we can develop our acceptability criteria based on our past experience. If this Z-score shall not show more than 0.5 variation or more than 1 variation, whatever we want to keep as our acceptability criteria. Or we can run controls on both the machines, and we can develop our acceptability criteria based on the controls. This we have already discussed. And what is bias? Bias or trueness is the difference between lab result and difference between lab result and reference material, or lab result and group mean. So this is how we calculate our bias percentage. Bias is a measure of accuracy. Now look at this formula. Total error in the lab. And we use another term, total error allowable. Sometimes some references they provide value TAE, all three are in capital TAE, total analytical error TAE, and another term again all three in capital TEA, total error allowable. Whatever it is, you have to understand one thing, total error allowable is provided to you in the references. There is one reference by C. Ricos, the other, or some reference is given in this Westgard website also. Whatever total error allowable is provided there, we have to calculate total error in our laboratory for any analyte. What is total error in our laboratory? Bias percentage. This we are getting from our EQUAS. CV percentage. This we are getting from our IQC. And with this formula, we can calculate total error which we are getting in our lab from the equation IQC, bias percentage plus 2.33 into CV lab. So this total error in the lab shall be less than total error allowable. And it should be as minimum as possible. If it is significantly less than the total error allowable, then we have some margin. Even if there is some inaccuracy or imprecision, there is increase in some inaccuracy or imprecision, it will not cross total error allowable, whatever error we are observing in our laboratory. So this is the importance of calculating this total error in our laboratory. And why we are carrying out all these activities? Our intention is we want to release correct patient result, which is meaningful for clinician, because 70% errors are detected. 70% decisions of the clinicians are based on our reports. One thing is this work on this IQC equals, we are checking our analytical system, but simultaneously it is also important delta check. With the previous results, you are comparing results. Suppose for last 3 days, patient urea results were 226, 210, 214. And today you are getting result 24. And it has automatically reached to clinician terminal because this is within our acceptability criteria. Normal range, the results has gone automatically. But when you are checking, you are finding that this is a case of CRF. Why his or her urea is 24 today? When you are asking in the ward, they are saying the patient has not received any dialysis. Then what is the reason? When you are calling sample again, asking for sample again, result is 210 only. There was some sample mix-up probably. This you realized when you compared result with the previous results. This activity is important. Clinical correlation is very important. Whatever clinical details you are getting in case of hematology, correct interpretation of histogram, correct interpretation of scattergram, these are important. Also analyze numerical data. What I mean to say, if suppose hemoglobin and hematocrit, ideally you are expecting a ratio 1:3. And in your automated system, hematocrit is a calculated parameter, MCV by RBC. MCV and RBC are using to calculate your hematocrit. If suppose there is excess EDTA, you will get low MCV and low hematocrit. Hemoglobin is estimated separately. So this ratio of 1:3 will not be maintained. If you are carefully watching this, then you will come to know there is some problem. Otherwise, you may miss this. If suppose some flags are there, suspect flag, see from your operation manual what is the reason, what is the action required. Sometimes some spurious results. TLC 20,600, patient is perfectly okay. When you're examining sample, it is highly lipemic. That lipemia is causing pseudoleukocytosis. Or no platelets, but in slides you are able to see platelets. These platelets got adhered to EDTA. We have to see all these things. Ultimately, what is our intention? Our intention is to release correct result. We are reviewing patient result. We are posting patient result correctly on clinician terminal on our website, or we are typing report to generate a hard copy, maintain patient record, critical results are informed immediately. For otherwise also, we are maintaining turnaround time. We are getting regular feedback from clinician and patients, whether they are happy with their services or not. And maintenance of all these documentation in a proper way is very important. Important is, sometimes people say, QC is needed only for NABL accreditation. I'm not going for any accreditation, so I don't need. Or sometimes people say, I have a small lab, so I cannot afford control. See, whether your laboratory is small or big, doesn't matter to patient. Patient is coming to your laboratory for a test. Patient want correct results. It is too expensive to run quality control, but if a patient is getting wrong treatment because of unacceptable result, then this expense is not bigger than that expense. Important thing is, everyone running a laboratory need QC, and QC comes at a cost. What is the information we get from QC? We get information about our equipment, about our reagents. We are getting acceptable results. And whenever there is any outlier, there is any inaccuracy, I get information about that and I can take appropriate vendor. Always choose very good vendor who is storing QC material properly. And when you are opening a vial, whenever you are reconstituting a reagent, you are reconstituting a control material, you are getting good stability. And store these, as we discussed, at appropriate temperature. And whether it need to be stored in the main compartment of the refrigerator or deep freezer. And there should not be any interruption in the power supply. You're dividing into small aliquots. You are thawing and freezing. You have to see you are handling this control appropriately, as we discussed. And staff shall have training about the QC material. What is required to add for reconstitution. And you're bringing this to room temperature before testing. And you're running correctly. You're using the correct comparison chart. And whenever there is outlier, you're taking appropriate action. What is required? The basic understanding of statistical concept, a good understanding of performing all these activities, well documented and well implemented procedures, understanding of Westgard rules, and how to use this QC calculator for inter-equipment comparison, and how to set mean, etc. of your laboratory. For everything, you shall have good knowledge, understanding, and also from within you, enthusiasm to work in a correct manner. Quality management procedures give confidence to the lab on their performance and reliability of reports. And it is also useful if you are planning to go for accreditation. These days, all of you know, now ICMR has made it mandatory, laboratory shall be accredited. Only then you will be allowed to perform this COVID-19 RT-PCR. In the time to come, you may get similar regulatory requirement for other tests also. It is better if we are developing our understanding, and fortunately or unfortunately, this understanding of quality is not mandatory in medical colleges. We discuss more our histopathology, cytopathology, hematology, or different aspects related to biochemistry, or theoretical aspects related to microbiology. But this understanding is very important. Ideally, these should be part of curriculum of the postgraduate teaching. And if something can be included even in the UG, QC in our clinical practice, QC in our laboratory practice, so I think that is a useful thing. How we can improve QC? By careful interpretation of control data, by following QC rules, and in a logical manner. Our aim is, with a little extra care, we can save one more life, or we can be instrumental in saving one more life. And now in Kerala, the cases have started increasing. In US also, we are getting a lot of cases. We don't know what the future has in store for us, but don't travel unnecessarily. Maintain social distancing, use face mask, good hand washing with sanitizer or soap and water. Stay safe and keep your body and soul together. Thank you very much.